Hello again, Tom from everystepcalculus.com, everystepphysics.com. I'm going to do a line integral on in Calculus 3 physics. This is right off of Paul's notes, his example. You can check it if you Google line integral. None of us are interested in line integrals. All we want to do is know how to do the problem to pass a quiz or a midterm. Very difficult. I've tried to find what does a line integral represent. In other words, what's the SI units for the answer that they get, and I can't find it. So that shows you something about calculus. To me, most of it is nonsense. Index 8 to get to my menu. I'm going to scroll down to line integral. I'm already there to save time. And we're not in a vector field. We're given the RT situation. And I show you the formulas. Here's the formula RT times the magnitude of the derivative of RT. And then this worked out. This is RT here. And then the magnitude, absolute value of R, derivative of R of RT is this. Write this all down in your paper exactly as you see it, so you look like you know what you're doing. And we're going to put the RT was given in this problem. We're going to do alpha before you enter anything into these entry lines here. Alpha 4 times second cosine of t alpha 4 times second sine of t. And when they don't give you the z, you just put 0 in, alpha 0. I always show you what you've entered. You can change it if you want. I say it's okay. And we start working out this is a vector here. When you have these arrows on the sides, it's called a vector, RT vector. We're doing the derivative of that, which equals minus 4 sine of t and 4 cosine of t, etc. And we do the magnitude, which is squaring those derivatives. And the answer turns out to be square root of 16, which is 4, really. And now we're going to enter the function given, which is alpha x times y to the 4th power. Where they dream up all these nonsense formulas of functions is unbelievable in calculus. I say it's okay. You could have changed that if you want. It's over the range of alpha minus pi divided by 2 to the range of alpha pi positive divided by 2. So here we have the range, and here we have the function, and here we have the the derivative magnitude of the derivative of our t function. And you do the calculations just to see them here on your paper over the range of this here. We've already done the derivative here. Here's the derivative of that. The answer is 8192 over 5. Notice how it's just an arbitrary number. We'd like to know area or something, distance or length or something, but it's just a number. So you have to decide yourself how important that is. I mean, to me, how important is the slope of a line, which is the derivative, or the area under curves, or volume under functions, under spheres and stuff. Have a good one. Go to my site, subscribe, and you can see more movies that I might make.